أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Class 11th Physics. Our today's topic is application of dimensional formula. Yesterday we have took the first application of dimensional formula. Now I may take our second application of dimensional formula to check the correctness of the correctness of physical relation by using dimensional formula. By using dimensional formula, we may take any physical relation. Let us take the physical relation S is equal to ut plus 1/2 of at square. It is an equation, second equation of motion. We check whether this relation is dimensionally correct or not correct. We apply the principle of homogeneity on both sides of this equation, on LHS as well as on the RHS, and equate them and show this equation is whether dimensionally correct or not. We know this S is a distance. Its dimensions are m0, there is no mass involved, L1, yes, and it is a length, then it is L1, and T is 0, no time involved here. For this velocity, it's velocity. We know that for velocity, we know that m is 0, L is 1, and T is -1. We know it. It is multiplied by also for time. Time is just, you can take just T1, M is 0, L is 0, plus, don't write this 1/2, no need of this, plus, we have to check it dimensionally. We don't these constant quantities. This for acceleration it is m0, L1, and T is -2, because per second square. For this time, this is T, but here T square, we can take T2. Okay. This T is 1 and this T is 1. T -1, they may cancel. This T is -2, this T is +2. These may cancel. So here again, m0, L1, T0. I can write here, it is equal to m0, L1, plus, I can write here m0, L1, just. It is m0, L1, T0 is equal to, this m0 to m0, it cannot be a 2m0. It is just m0. It is mass, it is dimension, it is not simple algebra addition of an algebra addition. m0, we can write 1, m0, L1, we can write L1. Now there is no T0. There is no T, here is T0. We can put here T0. When T is not present here, then T is 0. When M is not present here, M is 0. When M is not present here, for S, M is 0. T is not present, T is 0. There is only L, L is 1. There remains also only L. Because no M, the M is 0. No time, the T is 0. There remains only L. This L, L1 and L1. It is only L, not 2L1. Not 2L. Sometimes here may be M1 and here may be M1. It is only M1, not 2M1. So the dimensions of LHS is equal to dimensions of RHS. So this relation is dimensionally correct. We can take many other relations which are dimensionally correct by using this dimensional formula to check the correctness of dimensional formula. Okay. Now let me take our third application of this dimensional formula. Third, to derive the relation among the various physical quantities. To derive the relation relation among the various physical quantities. To derive the relation among various physical quantities, let us we can derive the expression for the various physical quantities unless and until we must know the principle of homogeneity of dimensions, and we must know on what factors this physical relation depends on each other. For example, if I am taking a centripetal force, I must know the centripetal force, this F. A body is revolving around a circular motion. There is a force which is acted towards its center, huh? which may tight it, but which may um, avoid it for escaping from its circular path. Okay, that is a centripetal force. We must know on which force this centripetal force depends. This depends on the mass of the body. It depends on the mass of the body. It depends on the radius of this um, uh, radius of the body from center of the circle and to the this body. And this force depends also on the velocity v. So I can say this F is, I can combine these three factors. F depends on mvr. So I can write F is equal to kmvr. What is k? It is a constant of proportionality. In SI units, we always take k is equal to 1. So I can say F is equal to mvr. F is equal to mvr. F is not equal to m. F depend. We should not take F is equal to mvr. No, 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 no. F is equal to k mvr. It depends on these three quantities. Now we may find the physical quantities, how much this F depends on m, how much depends on v, how much depends on r. We may derive by using this dimensional analysis. We may derive it. Let us take let us writing this F is equal to this mvr. Let us write the dimensional analysis of this force as well as this mass, this velocity, and this. Let us show it. M1, it is for force, there is a mass. Force we call ma, m1, l1, and a is acceleration, L1 t minus 2. It is a dimensions of force. So similarly, we can take the dimensions of mass. We know the dimension of mass is just m1. There is no length, there is no time. I can take here by principle of homogeneity the power a. Or power, it depends. First of all, I may take F depends m raised to power a, v raised to power b, and r raised to power c. F depends on m power. What I don't know what is the power of a. I don't know what is the power of b. What is the power of c? I have to find them. I have to find the a, b, and c. That m for mass m1 a, this a, and for velocity I can write. For velocity I can take this is equal to L1 and t minus 1 raised to power b. There is no mass in velocity. For radius, it is also a length. It is also a length. I can write here L1 in length. There is no mass. There is no time. So I can take m0 वो मैं नहीं लूँगा, t0 वो भी नहीं, power c. Okay, it may be m1 l1 t minus 2. It is equal to m 1, that is equal to A, added maybe into L, maybe B, B into 1, it is B, into T, it is minus 1, so it will be minus B, it is L, C. Now, in earlier, there were M1, L1, L1. We were not adding there to L1. Now, there is LB and LC. I can take like this. It is MA, L, add powers, B plus C, into T raised to power minus B. T raised to power minus B. Here it is M1, L1, and T minus 2. Okay, equating the powers on the both sides of the equation LHS as well as A. This A would be equal to this 1. A is equal to 1. This B plus C would be equal to this one. And B plus C is equal to this one. And this minus B would be equal to this minus B would be equal to minus 2. We can cancel this minus minus. So B is equal to 2. B is equal to 2. A is equal to 1. And we can write, instead of B, I can use this value 2 here in this equation. So it will be B plus C is equal to 1. Instead of, I can write 2 plus C is equal to 1. So C is equal to 1 minus 2, that is equal to minus 1. So C becomes minus 1. We got the three values. But we got these. We got B is equal to 2, A is equal to 1, C is equal to minus. We got all these values. So using these values in this equation, in this equation, which I have forgotten earlier. This F is equal to M raised to power A. I can do instead of A, I can take 1. Instead of V, I can take, instead of B, I can take 2. Instead of C, I can take minus 1. So use these three values in this first equation. I may got on how what quantity this force, centripetal force depends. This F is equal to M raised to power, instead of A I can write 1, V raised to power, instead of B I can take this 2, and R raised to power C, instead of C I can write power minus 1. So it will be M1, I can take F is equal to M1 तो कुछ नहीं, 1 power तो कुछ नहीं. This is V square. This is R raised to power minus 1. It is R raised to power minus 1. We can take it. F is equal to mv square R raised to power minus 1. It goes into denominator. That here it becomes R1. So we can write it mv square by R. So the centripetal force, the equation of centripetal force is F is equal to mv square by R. F is equal to mv square by R. Also, we have earlier taken the constant term F is equal to K mv square by R. This was our K, which we have taken that K is equal to 1 in SI units. If we remove this K, this F becomes F. If we remove this K, then it becomes F is proportional to mv square by R. So we can centripetal force is directly proportional to the mass of the mass. So we get from this is a body of mass m moving with a velocity v in a circular motion around this center O with radius r. So we can take this centripetal force which is applied toward the center of this body F. Its magnitude depends upon the mass of the body, directly proportional to the mass of the body, and directly proportional to the square of the velocity. and indirectly proportional to the radius of the velocity. If if this radius increases, if this radius increases, the centripetal force decreases. Mass increases, centripetal force increases. Mass increases, centripetal force increases. Velocity increases, centripetal force increases. In both the cases, as well mass as well as velocity. If we increase them, the centripetal force will increase. If we decrease them, the centripetal force will decrease. If we increase radius, the centripetal force will decrease. We have found this yeah, relation between the quantities in case of this centripetal force by using dimensional analysis. By using dimension, we can use, but unless and until we should know on which quantity they may relate with each other. We must know, just like force depends on mass, velocity, and this radius. We can find with this the time period of a sample pendulum, but we must know on which on which physical quantities the time period of a sample pendulum depends. Just like time period of a sample pendulum depends, we know it depends upon the length of a pendulum. It depends upon the acceleration due to gravity. We must know these things, and then we can find the equations of a sample pendulum. I hope you can do this by yourself. For now, its equation may be, you can find its equation will be equal to T would be equal to root of L divided by G, and here will be a constant term K. Instead of Q, I can write in for sample pendulum it is equal to 2 pi. We, we can find it. We can find it by using this sample pendulum. This is our L. We know that this is acceleration due to here. It is a rigid support here. This is L length of a pendulum. We can find its time period by using the dimensional analysis. If we know on what quantities this sample pendulum